Hello. Today we're going to be taking a look at Lesson 9-7, which is independent and dependent events. So first of all, just to remember, independent events have no effect on each other. So the occurrence of one does not affect the probability of the second. Dependent events, on the other hand, either the favorable outcomes or the total outcomes changes after the first event occurs. So when calculating the probability of two independent events, you need to take into consideration that each one can be found separately, and then you can multiply them. If you have two dependent events, you find the probability of A first, and then multiply it by the probability of B, which must be found after A has already occurred. So again, either your favorable outcomes will change, or your total outcomes will change, or both. A hint to remember, almost all the time, if you see the word and or the word both, you know that in a probability situation you will multiply. When you see the word or, as we learned in the previous two lessons, that's when you will add the two probabilities together. So to start, we're just going to answer if a few scenarios are independent or dependent. So A says flipping heads on a coin and then rolling a 5 on the number cube. Well, flipping heads is certainly independent each time you do it, and rolling a 5 would have no effect on, or would not be affected by flipping heads, so we would consider these two events to be independent. So we'll write an I there. B, selecting a red Skittle, eating it, then selecting another red Skittle. That obviously would be dependent. This time, you eat the red Skittle initially, so now you've taken one red Skittle out of the bag. That affects your favorable outcomes and your total, so that would be dependent. C, landing on a 2 on a spinner, then rolling a 2 on a number cube. So same number, but two different experiments. And the spinner has no effect on the number cube, so these would be considered independent of each other. Okay, next. In this next one, example 2. If the probability of A is 0.3 and the probability of B is 0.2, and A and B are independent events, find the probability of A and B. So here's the thing. If I know, it doesn't matter what the event actually is, but if I know that A and B are two different events and they're both independent of each other, to find the probability of A and B, I know I'm going to multiply. So I would take the probability first of A and multiply it by the probability of B. So in this case, that would just be 0.3 times 0.2. And when you multiply 0.3 by 0.2, you're going to end up getting 0.06. Which, as a percent, after you multiply it by 100, would be a 6% chance. In the next one, however, it says if A and B are mutually exclusive events, and we need to find the probability of A or B happening, that keyword or indicates that we will add. So here we would take the probability of A and add it to the probability of B, and that would be 0.3 plus 0.2. We're increasing our chances, which would give us 0.5, which is 50%. So when you're saying that you need both to occur, you're decreasing your chances. But when we say we need one or the other, we're increasing our chances, which is why we add them together. In example 3, if there's a 2% chance of you winning the movie basket in a raffle and a 1% chance of you winning the craft basket, what is the probability you will win both baskets? So these are two independent events. Each drawing happens separately, and you put your raffle tickets in separately. So we're just looking for the probability of both of them happening. So we want first the probability of winning the movie basket, and then the probability of winning the craft basket. And so we'll find them each individually. We already know them. So 2%, and we're not going to write that as 2. We're going to write it as 0.02. And then and means multiply, so we will multiply that by the probability of winning the sports basket. So then when we do 0.02 times 0.01 to find the probability, we get 0.0002, which after you multiply by 100 would get you to 0.02%. So it's very unlikely you would win both baskets. Not impossible, but a very small chance. In example 4, what is the probability of flipping a fair coin and having it land on heads 4 times in a row? So this is 4 independent events. Each one has a chance of 1/2, but the fact that we want them to happen consecutively, so we want the probability of heads, and then the probability of heads again, and then the probability of heads again, and then again a 4th time, is 1/2 each time. So when we multiply these together, we end up with 1/16, which would be 0.0625, which is about 6.3%. So not very likely at all. Okay, in example 5. It says there is a random drawing to determine the 2 captains of a co-ed ultimate frisbee team. There are 3 boys and 5 girls eligible to be captain. Find the probability that both captains will be boys. So we're assuming here that we have 8 names in a hat, essentially, and they're randomly drawing them to determine who will be the captain of the team. So what we have to consider here is that we want both of them to be boys. This is clearly going to be dependent events, and the reason is when you make your first selection, that will affect the second selection because it not only takes out one of the people, but so it could affect your favorable outcomes, but it also will affect your total. So first we'll find the probability of the first selection being a boy, which would be 3 out of the 8 total. So you also want to make sure you total them up. Then we also want the probability that the second one is a boy, but that's after the first boy has already been selected. So now there are only 7 names left, and only 2 of them are boys. So when I multiply these together, I'll end up with 6 out of 56 as my chance, which when I change that to a percent, I get about a 1.1% chance of getting 2 boys in a row. Okay, next, a snack bag has 8 regular Doritos and 7 Cool Ranch Doritos. Sarah reaches into the bag and pulls out a Dorito, replaces it, and then pulls out another. So find the probability of her pulling out a regular and then a Cool Ranch. So we're assuming here these are obviously going to be independent. The main word that gives that away is that she replaces it. If she puts it back, then her initial probability will not affect, or her initial pick will not affect the probability of her second pick. So we would then go ahead and calculate the probability of both of these happening. So first we want to find the probability of her selecting a regular, and then multiply that, because the word was and, by the probability of a Cool Ranch. So the probability that the first one would be a regular, again we have to find total, so add those up, that's 15 total. Regular would be 8 out of 15. Then we will multiply that by the probability of a Cool Ranch, which would be 7 out of 15. And then when we multiply those together, we would get 56 out of 225. If we change that into a percent, it's about 24.9%. Okay, same scenario, but now Charlotte reaches into the same bag. She pulls out a Dorito, eats it, and then pulls another one out. Find the probability she got 2 regulars. So these would be dependent of one another. So the reason being, she eats the first one. So her second pick was affected by what she took out the first time. So we're looking for the probability that the first one was regular, and then that the second one was regular after the first one was already selected. So the first one being regular is still going to be 8/15. But the second one being regular will only be 7/14 because she's already eaten one regular, which means the total is affected and her favorable outcomes is affected. So we will multiply and we will get 56 divided by 210. And as a percent, that's going to give us about 26.7. Okay, lastly, it says, what is the probability that Chuck pulls out 2 of the same Doritos? So what's very interesting about this is there's 2 different scenarios which will impact it. They could either both be regular or they could both be Cool Ranch. So we're looking for the probability of, well, we'll say it like this. We're looking for the probability of a regular and a regular. Or the probability of a ranch and ranch. Okay, so we already know the probability of a regular and a regular. That ended up being the 56 out of 210 that we just found out in the previous example. The probability of it being a ranch and a ranch, we would have to calculate this. So it would be 7/15 times 6/14, because they would be dependent, which would end up being 42 out of 210. And because we're looking for either of these possibilities, and I'm keeping them in unsimplified form for now, that word or indicates that we are adding. And so when we add these 2 ratios together, we can just add the numerators, keep the denominator. We would end up with 98 out of 210 as the possibility of you getting either both regular or both ranch. As a percent, that would be 46.7%. Okay, next, in number 7. It says Jack has a bin of white, black, red, and multicolored shirts. The number of shirts of each color is shown in the table below. Jack randomly selects one shirt, records its color, and returns it to the bin. She does this 3 times. What is the probability that Jack selects a red shirt, and then a white shirt, and then a black shirt? So these are independent events because he puts them back in. We would want to find the total, so let's add them up. It ends up being 20 total shirts. Now I want to know first the probability of a red, and notice these are all ands, so then we would multiply that by the probability of a white, and then multiply that by the probability of a black. And so the probability of red would have been 4/20 times the probability of a white, which would be 12/20 times the probability of a black, which would have been 8/20. Now all of these would have simplified. So you could have 1/5 times 3/5 times 2/5. When we multiply those all across, we would get 6 out of 125, which as a percent is 4.8%. Okay, and then the last question, example 8. Jill rolls a 16-sided die as an experiment, and it tells us that there is a 1/4 probability she will roll a number that's a multiple of 4, and a 5/6 probability that she will roll a number that is prime. She rolls her 16-sided die 2 times. What is the probability that she rolls a multiple of, I should say 4 on the first roll and does not roll a prime on the second roll? So the first, a probability of getting a multiple of 4 is 1/4. And in the second one, it's the probability of not prime. So probability of getting a multiple of 4 was 1/4. The probability of getting a prime was 5/16, but the probability of not getting a prime would be 1 minus 5/16, which would be 11/16. So to find this probability, we would do 1/4 times 11/16, which would be 11 out of 64. And then I divide 11 by 64 to get my percent, and it's about 17.2%. Okay, thank you.